This is the complete MATLAB code to generate and plot the square wave. To simplify this code, I divided this code in three blocks. First block contain parameters. Parameters, that is fs, stands for sampling frequency. Capital T, that is duration of plot. Small f, that is frequency of our square wave. Small t, that is time vector, that starts from 0, goes up to capital T with the spacing 1 over fs. Second block, expressions are written to generate the square wave. In the third block, codes are written to plot the generated square wave. Get back to first block. First block, fs. When we generate a waveform in MATLAB, we are actually sampling a continuous signal at discrete point. These discrete points are 0, 1 over fs, 2 over fs, 3 over fs, 4 over fs, and so on. Hence, fs is the sampling frequency, means 1000 points in 1 second. Now capital T, that is 1. This is the duration of our plot in second. Small f stands for frequency of our square wave, that is 5 Hz. We can find time period from this small f. Time period, that is 1 over 5. This is 0.2 second. Small t stands for time vector, that starts from 0, goes up to capital T. Second block, expression are written to generate square wave. Expression is 2 star, pi star, f star, small t. Small t is the time vector, f is frequency, pi is the value of pi, and 2 is the multiplier. This expression gives phase value at each time instant in radian. Now square function generates a waveform that alternate between +1 and -1 based on the sign of the phase. If the sign of this phase is positive, the output y is +1. If sign of this phase is negative, output of this value of this y is -1. Third block. In the third block, codes are written to plot the generated square wave. First line is figure. Using figure, we ensure our square wave plot appears in new window, keeping it separate from other plots. Second line is plot. T, y, line width, 1.5. T stands for time vector. Y is the signal value at each time point. Line width, that is 1.5, sets the thickness of line to 1.5 point. A thicker line improves visibility. Grid on. Grid line help visually align the points on the graph and make it easier to read amplitude and time values. Now X level. It levels the x-axis as time, that is second. Similarly, Y level. It levels y-axis as amplitude. Now title. We add title to the plot, that is square wave. Now axis. We set axis limit as x minimum, x maximum, y minimum, y maximum. Okay, x minimum, that is 0, x maximum, that is 1.2, y minimum, that is -1.5, and y maximum, that is +1.5. Now we will run the code. We can check the generated square wave. Frequency was 5 Hz. We can see the time period 1 by 5, that is 0.2. This is the time period of square wave. 0.2. Now we see the x-axis vary from 0 to 1.2 and y-axis vary from -1.5 to +1.5.